All right, welcome everybody to GlugNet. Tonight we are pleased to welcome Brian Gorman, who will be speaking to us about serverless solutions in Azure. For those who don't know, it stands for the Greater Lansing User Group for .NET Developers. We are based out of Okemos, Michigan. Meetings are held every month on the third Thursday, free for all to attend. That QR code there will take you to our meetup site, where you can find out more information about past topics, as well as some future topics that we're scheduling. I'd like to take a moment to recognize our sponsors this evening, NIS Technologies, who is giving us this virtual meeting space, as well as the recording capabilities, JetBrains for a software license that we will raffle off later on, the .NET Foundation, and TechSmith, who is our normal physical hosting provider. Obviously now with COVID, not so much, but still like to thank them for all their service to GlugNet. As mentioned, the meetups are recorded and posted to YouTube by Sam Nasser on his YouTube channel. We'll drop a link in the chat, and there is a QR code there as well if you would like to go see past recordings or subscribe to see when this recording is posted. If at any point you have a question, feel free to unmute yourself and ask the question, or if our speaker is asking a question, you want to answer it, you can answer, certainly. But if it's not one of those scenarios, please remain muted so we can all hear and enjoy the presentation. If you're uncomfortable speaking up, but you still have a question, there is a chat feature as well that we'll be monitoring, and you can submit your questions that way. At the conclusion of tonight's presentation, there will be a survey. A link will be provided in the chat. That's completely anonymous. All the feedback will go to Brian in order to help his presentations. So highly encourage you to fill that out at the end of the presentation. And as mentioned, special thanks to JetBrains, who is providing us a free personal license to a product of your choice. That includes up to 12 months of updates on them. At that point, you can either pay to continue to get updates, or you just stay on the version that you landed on. It's a great offer, and all you have to do to be eligible for that is complete that presentation survey at the end of this presentation. And now, time for our feature presentation.
We need the music, like the you know.
I'll work on that for next month. Yeah,
the movie presentation. Everybody gets their popcorn, starts eating.
That's right.
Well,
all right,
thanks
I'll
so
make
much
you presenter here.
Cool. Thanks so much for having me, you guys. Thanks for the opportunity to speak to your group here. I'm going to go ahead and share my second screen, so hopefully you'll be able to see that okay, and hopefully I'll be able to interact with you decently throughout this and run this on 2 monitors. So hopefully you see my screen now, and if you have any questions, like he said, just go ahead and butt in. I am perfectly fine with you interrupting me so that we can, address anything. Also, this is a very broad overview. So, if we're talking T-shape, we're on the top level of the T. We are going to go a couple of levels deep on a couple things. But if you want to see something deeper, or if you're curious about something, please don't hesitate to ask. And as to the best of my ability, I'll try to dive a little deeper or go deeper if we can, or find answers for you afterwards if we can't find them while we're here. So just real quick, who am I? This is me. I'm Brian. I'm the honor of being an MVP with Microsoft, which allows me to do things like this and share my knowledge with the community, and it's just a really great honor to do that. I just recently released the second edition of Practical Entity Framework 6. It's on Amazon if you're interested in that type of thing. I have an MCSD from back in the day, and then a bunch of Azure certs because I'm an MCT, and having Azure certs lets me train you. So if you are interested in anything about Azure certifications, I love talking about them, helping you find resources, whatever you might want to do on that. You can hit me up on Twitter at @BLGorman or connect with me on LinkedIn as Brian L. Gorman on LinkedIn there. And yeah, so as long as you're not trying to sell me something, I usually connect on LinkedIn, so no big deal there. I just wanted to take one quick moment to tell you about this program that I run, and this is just kind of a shameless plug here, but I do have a certification program that I do. It's a little bit unique. If you're interested in that at all, I'm happy to talk to you on another note, on another time. Okay, so with that, we're going to go ahead and we're going to dive into some Azure Serverless stuff. Now, as we were mentioning beforehand, I did run this in a 4-hour workshop at CodeMash just a month, beginning of the month here over in Sandusky. It was quite fun. We did go through the actual workshop that we'll talk about here at the end. But what I'd like to do today is just concentrate on the overview part, where we're basically going to talk about what platforms and serverless things are available for us at Azure that we can use within our .NET solutions. And ultimately, we'll talk about some guidelines, some architecture things along the way. And I have a couple of small, simple code demos that I worked up just to kind of help us, since this is a .NET user group and we're probably mostly interested in the .NET developer as Azure user type of scenario. I thought a couple of quick little code demos might be more useful for this one that you wouldn't ordinarily see maybe on a normal presentation, just because this is user group. I thought that'd be fun. So I wanted to talk about some of the different platforms that we're going to use, and that at the end of the day, there's a serverless solution out there from a Microsoft Cloud workshop, and I want to take you through kind of the solution on that, just kind of talk about it in general, see how it looks, and point you to the resources for that if you want to try to play around with it on your own. So it's really cool stuff. That's actually the workshop part that we ended up doing at CodeMash, but we had the full 4 hours, and I know most of you probably don't want to give up 4 hours tonight, so we'll probably let you go maybe after about 2.5 or 3, right? Just kidding. We won't keep you that long. And then also we're going to dive a little deeper on some of the other platforms as well. So what I wanted to do was first just talk about some of these things, and I'm more like to get my hands on, so talking about things in general is okay, and I like it, it's fine, it's nice to address it, but I have a lot of different things I want to show you in the platform as well. So hopefully you're ready for that. It's going to be a little bit of craziness, but we'll get there, and we'll see some of the different tools and things as we go. So I'm a developer. What the heck can I do with Azure that I can't do on my own premises or on my own machine? Well, pretty much everything you can do on-prem, you can do at Azure. It's just a matter of maybe making a few tweaks here and there, making it so that I can actually change a few things around. But really what it comes down to, and what I've found with most people, is what's even available. Azure's so big, the ecosystem is giant, and I don't know what I'm using. And then there's these weird like FOMOs or something that start happening when you don't really know what's at Azure, and you're kind of like, well, I think I want to use this thing, but what if I should have been using that, or what if I should have been using the other thing? And I've spent a lot of time talking with people about this because it's a big deal. You start working with Logic Apps next week because you heard they're great, and you start working with them and you're like, oh, these are great. I should have been using them for the application I did 3 months ago. But then you're mad at yourself for something you didn't realize existed. So that's not fair to yourself. And the same thing goes in the other direction. Well, maybe you didn't know about Azure Functions right now, and the only thing you knew about was Logic Apps. And Logic Apps maybe has a lower barrier of entry because it's low code. So hey, let's try that. And you know what? They may not work as well as an Azure Function in some scenarios, but that's all we knew. So let's not beat ourselves up. Let's be happy we did some stuff, we got it to work. That's what matters at the end of the day. And then of course the cost, right? We want to get the cost optimized, but that's a whole other story. So what can we do with Azure? We can do web solutions. We can do containerized web solutions or traditional web solutions. You can do .NET 4.7, 4.8, whatever you want to do in the old .NET framework. You can do .NET Core 3.1, .NET Core 6 now is available as of some recent updates that we had as of last November, so that's awesome. And then there's the storage. So basically, storage is going to be the backbone of everything we do. Whether we create Azure Functions, or if we're writing websites, or whatever we're doing, at some level, storage probably is going to come into play. Even if we're doing some sort of lift and shift architecture where we're deploying networks and virtual machines out at Azure, there will still be some storage behind the scenes. So storage is kind of the the baseline place where we land. And we create storage accounts. Inside of storage accounts, we have containers, and inside of there, we have different things. I'm going to show you some examples of that in a little bit to kind of help us see that in general. And storage is a little basic, so maybe you already know that stuff. So if it is, just kind of bear with me as we go through that part. But know that we can do, that kind of thing very easily, and we can use code to work against it, which is really fun. So then, of course, there's data. We move our data from our on-prem to the cloud, where we have SQL Server. We have Azure SQL, which we can do the fully managed solution by Azure, or we have, maybe we want to set up a VM and just deploy a SQL Server on it. We can do that as well. The real fun really starts when we start doing our serverless stuff now. So the traditional web development, sure, we are all pretty good at that probably, but when it comes down to disconnected microservices, serverless, all these keywords that we're hearing, we're like, what do we do? And you kind of feel like maybe a little bit overwhelmed. Well, what it comes down to is really just figuring out some of these patterns and the architecture that you need in order to start doing things with things like messaging and events at Azure, handling those as they happen and making sure that you're responding to them correctly. And then, of course, just the different processing that comes around that. Along with that, I would be remiss if I didn't mention other platforms that you may not typically encounter, but are considered to be serverless and available for your solutions. And the big one really is cognitive services and the AI space. At this point, you can actually do things to modernize your apps with cognitive services and AI at Azure. For example, you can build out your favorite chatbot that you always get when you go to a site and it says, how can we help you today? And you start chatting, and eventually you say, please get me to a customer service, right? But we can build that bot for everybody else if we'd like to, and give them access to a document repository that literally will let that AI go out and search against our Word documents to find instructions on how to help them with things on our websites or within our solutions, and thereby hopefully free up our customer service reps to answer calls that are actually more, more involved and actually do require human interaction. Big data is also a big player as well, and especially if you're looking into data science and that type of machine learning arena where you can start doing massive processing of multi-million records a day or whatever it might be, bringing in all this big data and then trying to find the patterns around that. All of that can be done with different platforms at Azure. And finally, a fun one that I think often gets overlooked, but as a developer, if you haven't looked into, you're missing out, is IoT. And the little fun stuff that you can do with little devices and just building out little sensors to do things. And sure, some of our examples are pretty academic and also kind of contrived. Talk about walking through, looking at the sensors on a factory floor to see if a line has too much vibration going, so the belt might break, or potentially, a truck has a trailer that the temperature is too warm, so now the ice cream is going to melt. Those are kind of the examples we would work with, but you can take those ideas and you can say, wait a minute, there are some things I can do with this IoT. And, there's actually a certification around IoT as well, which is quite a fun thing to study for, just learning all that stuff. But streaming the data, getting telemetry from all these disparate devices all over and figuring out how to process that with code, and then also work with that in your different Azure solutions, such as the IoT Hub and such. It's actually quite fun as a developer, and I recommend looking into it if you haven't already. Cool, so let's home in now a little bit on each of the technologies here. So as we start to learn about working with the web, we talk about things about what we've done in the past and make them happen at Azure. The typical entry point into Azure is either lift and shift your current architecture to retire a data center, or potentially, remove some servers that you're managing and put them out into the cloud, so you can get what we call the shared responsibility model, where we actually delegate that stuff out to Azure and say, okay, I no longer want to buy servers every 6 months or 2 years or whatever it might be, or I don't want to be on call at 2 a.m. because the network card broke again, or whatever it might be. You can delegate that work to Azure. So typically that lift and shift is the entry point, but then what happens is, as you continue to adopt the cloud, you start doing more cloud native development. And a lot of times when people say cloud native, they actually mean containerization. But as a .NET developer, most of us probably haven't done a lot with containers. And so containers might even be a little scary because it's a whole other ecosystem. We got Docker. We got to learn all these Docker commands, which is just as bad as learning Git, right? There's so many commands. How does this work? Why does it do this? I got to push it where? I got to do what? So you can do that, but the great thing for us, if you're not into containers, is that you don't have to. And you can keep doing what you're supposed to do with an app service. And you just literally push a few buttons and you can get your deployment from GitHub or from Azure DevOps right out into your app service. And that will give you the chance to do that. With the containers, however, the ecosystem is there. So Docker, if you're not familiar with it, is just it's a protocol basically, or whatever, a runtime on your machine, the runtime that does the containers and runs containers. When you create your container, you have to have these images of the container. You push it to a registry. Typically, that's been Docker Hub, but Azure has the Azure Container Registry. And the container registry is just like Docker Hub, but it's private to your Azure subscription. So you push your containers there, and then you can use those in your applications for deployment with a push of a button or connecting your services either to container instances, which is kind of the lightweight, very simple, get a container up and running, very, very low cost way to get a website out there. Build an Azure container instance. And ultimately, within a few clicks, you've got this thing up there. It's a public facing website. You can use it just like any other website, but it's running off a simple container or a container group perhaps. But if you have a major need for containerization with orchestration, there is Kubernetes. Now, Kubernetes is kind of the buzzword, and everybody's like, I got to Kubernetes all the things. But from most of the conversations I've had around Kubernetes and just a lack of personal experience with it, I'm hesitant to say Kubernetes all the things because I think that there's real good reasons to use it, but I'm not sure a lot of us have them. And so we tend to maybe over orchestrate or over architect things sometimes, and people say Kubernetes is the thing. Sure, maybe it is for them, but maybe not for us. And so as a .NET developer with traditional web apps and traditional .NET architectures, not necessarily working with containers, that may not be the area I want to go to. But if you do need orchestration, if you do get massive processing and you need that to happen, you can do Kubernetes. Now, the good news is, because Kubernetes also has a learning curve with all the different things that are going on behind the scenes with the pods and the management of that and the life cycle and all that jazz. The good news is there's this new thing called Azure Container Apps. And Azure Container Apps is a solution that basically puts a wrapper around Kubernetes. So we don't have to learn Kubernetes. If we need Kubernetes type of functionality for containerized applications, Container Apps might be our solution. Now, it's pretty new, and I've not even played with it yet, and I intend to, but I just haven't had the time. But it's, from what I've heard, pretty good, and people are liking that you don't have to do all the lower level things that you would do with a Kubernetes service. So those are kind of our traditional web app approaches, where we have, a web app we want to deploy, whether it's through a container or through our traditional .NET. We just push our application out there like it would have been on in the past, like an IIS web server. Now it's on an Azure Platform App Service. And I forgot to also mention, you can also put containers into an Azure App Service. So Azure App Services are kind of our main landing point for our mid-level, low production value type of services right away. You go to an app service. Now, once I start deciding that I want to go into this microservices world, where maybe I'm not doing a full monolithic web app anymore, I just have functions or I just have units of work that I want to separate into what we'll call microservices. There are other ways to go about that, and the typical place we go as developers is Azure Functions. And a function app is very easy to construct within the .NET ecosystem. In Visual Studio, you just create a function app, and then you can select the properties of that function that you want to do as far as what its entry point trigger is going to be. And then you just write your C# code or your .NET code, and you can push that function app out, or you can put it into GitHub and with the push of a button again, have an automatic deployment to your function app. So that's kind of our first level coding entry. Now, the cool thing about function apps is that you can also use different languages. So you don't have to use .NET if you like Java for some reason, or Python, or if you even just want to run a PowerShell script. You can put that into a function app and deploy that out into Azure. And in some cases, if you want to, you can even write your code in JavaScript in the portal, and you don't even have to have Visual Studio or anything. You can just literally just go to the portal, write some JavaScript, and have an Azure function working. So there's some other things that go a little deeper with Azure functions as well, like different types of functions. The traditional Azure function was built in order to work very lightweight and spin up and take about 5 minutes to run or less. And they've actually greatly enhanced that ecosystem now. We have these things called durable functions as well. And finally, the cool thing about Azure with the web solutions that we need to kind of address is the fact, again, that with Azure Web Services or anything at Azure, we have built-in monitoring. And so we can use application insights on our applications, and we can track and monitor the things we're doing. We can write custom code that will give us a chance to throw events into the logs. We can review those logs with a thing called Kusto queries. So there's a little bit of learning curve on Kusto queries. It's a little bit deeper, but it is something that you can definitely do to find things like what's happened to my server in the last hour. What have I done? You know, what events have been thrown? What pages have people been visiting? You can track that sort of thing. Cool. So again, we're just kind of doing an overview here. We'll go a little deeper when we get into some demos in a minute, but ultimately storage is going to be our landing point. And there are a few things you need to know about storage in order to just basically be dangerous enough to use it within our ecosystems. And so really the main things about storage is what kinds of storage are there and when do I use each? Well, our typical work, most of what we do, probably I would say about 95% or better for most people will be just simple blob storage. And what happens is everything we do at Azure, we're going to see as we start working through some code examples in a little bit, kind of as a hierarchy. And we have this account level, and then under the account level, we have some sort of like container or some sort of like service level. And then under that, we actually have things. So when we deploy a web app, we have the app plan, the app service plan. And under that, we'd have the actual app service. And then the app service has our code. Well, in storage, we have the storage account. Then we have the container. And in the container, we have blobs. And the blobs are just binary large objects. So basically binary data, storing, it could be files, it could be documents, it could be music, it could be videos. It's basically designed for unstructured data. And for the most part, that's what we'll use. We'll use that to store images for our websites or documents people are uploading that we're going back and forth on getting signatures, whatever it might be. And within that storage account, we have the the ability to set different tiers as far as our access level. So you can look into that more if you want to talk about how much are you going to be accessing it versus how much do you just need to have access to it. You can go from a hot tier to a cool tier, and then there's also an archive tier if you just need to keep it around but don't need access to it directly. When it's not good enough that you have a blob, if there are other specific scenarios that you need, there are other types of storage. So another one is the file storage. The file storage is going to be used to typically represent something like a SAN disk that you would have, a storage area network disk you would have at your on-prem. It's in a lift and shift type of thing out at the cloud. You create a file storage, and it's basically served like any other SAN disk would be. The cool thing is it has all the SMB protocols that you would expect. So if you've written applications to network and work against your SAN drive or whatever it might be, with a few connection string changes or whatever it might be in your code, you should be able to work against your Azure Storage account with no problems. Table storage is going to be your lightweight key value pair. So this is where you can get kind of a NoSQL entry point for a lot of people. And it's lighter weight than Cosmos and typically has been cheaper than Cosmos, although now Cosmos does have a free tier. The table storage gives us a chance to do key value pairs that are very simple, unstructured data with JSON documents, basically. And then there's a queue storage. And I argue with myself a lot or with people I'm talking to, but why we call storage queues, because in my mind, if I say queue, I think first in, first out, right? FIFO. And in storage, that's typically true, storage queues. However, there is no guarantee of order. So if you are using a storage queue, just remember that typically it will be in order, but there isn't a guarantee it will be. So it's not a full, in my mind, queue, but yet it's called a queue. It works like a queue. It's got messaging. It's got the ability to, have your messages coming in and being read by different readers. And you can have lots and lots of messages because it's Azure Storage. But again, there's a little bit of a disconnect with the storage queue not being guaranteeing order, whereas a service bus queue is specifically designed to guarantee order. So I have an example of that for us in a little bit as well. And then finally, we also have storage, which is going to store things like our Azure or like our VM disks. Typically, we used to manage that. Now it's managed for us. So that's cool. But we also have recovery services. So if we have VMs or other different things that we need to have backed up that we're doing, we can back that up into a recovery service vault. And what happens then is we can restore from that if our VM goes down or something. So that's basically storage for us. The simple high-level look at data is going to be just like you would expect as a .NET developer. You'd have Azure SQL. The difference is there's 3 tiers of it. And so what do you choose and when? Well, if you're a greenfield app and you just want to get something out to the cloud, Azure SQL is going to be your best bet. The cool thing about Azure SQL, it's a platform service, so you don't have to pay for licensing because that's baked in. You don't have to pay for a VM because that's baked in. And you just get the ability to have the leverage of a very high SLA because it's an Azure platform service. And you have the ability to have that being backed up for you. So you don't get as much control when you have a platform service because you have no access to the underlying operating system. You're basically just relying on the Azure data centers to host your SQL Server, and you only have access to that SQL Server. So if you need full control, the real solution is to deploy a VM and deploy SQL Server on it. And the cool thing is you can use a hybrid benefit on this as well. So if you already have paid for an enterprise license of SQL Server for your on-prem, you can put a SQL Server VM on Azure and reuse that license in the hybrid benefit. You get the full control then. You're also responsible for all your backups. You're responsible for setting up your high availability and disaster recovery, which means you have to make sure that you have your failover. You have to make sure things are in place for that. But ultimately at that point, you have the control. If, however, you want something in the middle, there's a little bit of a more expensive option, but it gives you a little more power. It's called the Azure SQL Managed Instance. So in this case, you get the benefits of the platform service, including automatic backups and the high availability baked in. You're also getting the SQL service baked into that. You're paying a little bit more money though, because you're going to get an isolated tier of control, which means now I can get back to the operating system. So it's kind of the best of both worlds and you pay for it, but you do have the full ability there. And just a couple of quick caveats, the Azure SQL Managed Instance and the Azure SQL VM, you can take your full copy only backups. The Azure SQL platform, you cannot do a full copy only backup. You can only export a data tier application and then import that data tier application. So that's the big things there. If you don't like SQL, you got Postgre, MySQL or MariaDB options are available. All of those are platform services. So they again don't have access to the operating system. And so therefore you are reliant on whatever Azure's doing there. And if you're in Postgre and you needed to run some of these store procedures that have access to the underlying operating system, you wouldn't be able to. And if you're using Postgre and you know what those are, then you would know why that's important to you. And if you don't, then it's not a big deal. And then finally, for data, we have the NoSQL options. So this is kind of the new thing as well. For most of us, it's new, where it's basically like, oh, there's this cool thing called NoSQL. How do we use it? Well, we have MongoDB, which was kind of the big player for a long time. And ultimately, we might have written applications in MongoDB. And so Cosmos at Azure has different services that you can choose when you create your Cosmos. Now, typically you want the SQL API, especially if you're doing new development. That's what they call the basic Cosmos NoSQL database, is a SQL API. Now, don't confuse that with Azure SQL or T-SQL. It's similar, but it's not the same at all. And your queries are going to be a little different, but kind of the same. So it's really weird, but it's out there. And if you have already written applications in Mongo or Cassandra or even table storage from Azure, you can port those into Cosmos. And again, with the change of a connection string, you should be able to work against that data just like you were working against your old MongoDB or your old Cassandra. But if you're doing greenfield, unless your team has skills, they're not recommending that you go to pull up a Mongo API or a Cassandra API. And Gremlin API is out there for graphing. So if you have to do a graph database, you want to use the Gremlin API. I also wanted to mention Redis Cache, because Redis is a very big player as well, and an opportunity to do something other than Cosmos. So if you just wanted to look into Redis Cache, you can deploy Redis Cache through Azure, which there are some benefits to doing that because you don't have to manage the Redis setup, which I understand can be a little bit intense at times. So with a couple pushes of a button, a connection string, and a few commands, you can be working against Redis Cache from your applications very easily. They also provide you migration services. So if you want to migrate an existing database, you can do that usually through one of their tools. So where we start to really get fun with .NET development and with just working in the serverless is when we start talking about eventing and messaging. It can also be a little confusing. When do I use which, and how does each one work? So there are some different players that I've listed here, but again, the big ones are going to be the Event Hub, Event Grid, Service Bus for most of the stuff we do. And Storage Queue also is a player here as well, so it's worth mentioning. But when you're first entering, well, you see Event Hub and Event Grid, and you say, what are these and what's different about them? And why, how do I use them and when? And what's a service bus and what's that for? Well, the cool thing is that each one of them is for a specific reason. And once you understand that, using them in your applications becomes second nature, because you're like, okay, I need this type of thing, so I'm going to use this specific service. So to differentiate these, when you start working with serverless, you're going to have a couple different things that could happen. Number one, you need to use some messaging or some queuing to disconnect your applications. And you want to be able to separate the load by having basically entering messages into a queue from one side and responding to the other. And that's typically going to be done through a service bus. A service bus is going to be your messaging solution for most reasons. Now, when you do things at Azure, no matter what you're doing, stuff is being recorded behind the scenes. For example, if I create a storage account and I drop a file into storage, there is an event that is fired within Azure that says, hey, there's a blob created event that just happened. Or if I'm doing something else where I do send a message to Service Bus, there is a message event that happened. So outside of the messaging between my applications, I may need to do things when things happen at Azure. And the typical example of this is dropping something in storage, responding to it, whether it's someone uploaded a file from my web app and I need to respond to that, or process that through an Azure function, then I'm going to respond to the event grid. So the event grid is going to be for my one-off events. And everything at Azure, again, is going to have some monitoring going on, and those monitorings will record the events. So then it's just a matter of creating subscribers to those events and then telling the event subscribers, what they are and what they should do with it. And typically, again, that's going to be like, okay, we dropped a file into storage, let's fire a logic app, or let's fire an Azure function based on that event that happens. So then you have the Event Hub. The Event Hub, when you hear that, you should think big data, because what the Event Hub is for is streaming millions of records per second. And the Event Hub has some architecture that goes on. There's partitions inside of there. And what's happening is it makes it so that you can have multiple people or multiple consumers reading from those event streams. The cool thing about Event Hub is it has replayability. So I can go back in time and look at postmortems. I can do some stream analytics around it and see what's happened for the last hour, time series windows, types of evaluations on all of this streaming data. So you might also guess then that Event Hub is kind of the backbone for IoT Hub as well. IoT Hub is a subset of Event Hub. And in fact, as coders, when we write code with .NET, the library to write against the Event Hub and the library to write against the IoT Hub are pretty much the same thing. So IoT Hub code works like it's writing against the Event Hub. So those are my eventing and messaging and how I would work with those in code. So again, I have my serverless processing mechanisms that are my main places that I might write code or work with serverless processes. So Azure Functions is going to be the big one. I'm going to deploy an Azure function. It has a different trigger on it. The trigger might be an HTTP request, or it might be an event from the event grid, or it might be somebody posted a message on Twitter and I need to respond to it, whatever. It might be Twilio sending me a notification, or somebody SMS'd our system and they need help, or whatever it is. You can put these different triggers on your Azure Functions and your logic apps. And the difference between a function and a logic app is really the amount of code you write and kind of their purposes. So again, in the past, functions were designed to run within 5 minutes and be a fire and forget type of thing and be done. And if they went over 5 minutes, in fact, they would time out to try to save you money so you didn't get into an infinite loop. Well, now they have a thing called durable functions, which works in every language except Java. Because Java, I think there's something with the JVM that makes it that doesn't work. But ultimately, the Azure Functions with durable functions now can run and store state, which wasn't the original intent. So they've added that into the ecosystem because there was enough requests for it, and it's highly useful. You can do things like store user settings in an Azure function, in a durable function, and then you can use those user settings in your apps. Every time they come back, sign in, you just call the function and use those settings that are already stored. The cool thing about a durable function is its life cycle lives past the app recycle. So if I restart the function, my durable state is still maintained. Now that's also a bad thing because that means I have to clean it up if I want to have a refresh. It doesn't just get wiped out by my restart. So if I'm going to write code, I'm going to handle things that are more intense with code, I'm going to use an Azure function. But if I just need a workflow where I just want to take something and do a few things and I don't want to write a lot of code, I'm looking at a logic app. A logic app is going to give me the ability to use connectors to work against different services. So drag and drop, I can connect to Microsoft 365, I can connect to SharePoint, I can connect to Twitter, I can connect to Twilio, I can connect to whatever I need to. There's at least 200, I think there may even be up to 400 at this point, connectors. You pay for execution on the Azure Functions and logic apps basically by the executions as a consumption plan. And so what happens is with the function, you get a bunch of them for free. I was reading the other day, I think it's like 1 million executions for free, and then you pay after that for a consumption app. But it does have a cold start if you do that, so that's a whole other story. But then the logic app, you pay per action that executes. So you need to be very careful in your architecture that you don't add extra actions, and then once you have that, you just pay for each one. So it's really cool because the logic app is a drag and drop. There's very little code. You just enter some settings like this is my connection string, or this is how I connect to my Twilio or my Twitter, or this is my SendGrid API key, and I can send an email with a push of a button. Or someone uploads a document to storage, I respond to that as an event, and I run my logic app without me even being there. So low code executed by an event at Azure, it's pretty fun. There's a couple of other processing environments you should be aware of. Batching, which allows me to perform batch services, typically on batch VMs, like burstable VMs, and you would just spin them up and run your code or whatever. You might do that through some Azure Functions as well. But then there's also automation. And automation allows me to set up some Azure PowerShell scripts and things that I want to run in automation runbooks. This is more typically going to be useful if you're an admin and you need to do server configurations or check for configuration drift, or even check to see if incorrect resources have been deployed into resource groups and such. The automation account is really great for that kind of thing. Again, the cognitive services gives me the ability to quickly look into using AI and cool. How do batches differ from logic apps came up, I think, on the question there. So a logic app is going to be very low code, and it's going to essentially process, by some trigger. And a batch is going to be something like I need to process 1 million files and put them into my database or whatever it might be. So I can burst up a VM that has an Azure or a Windows service or something on it, even or some sort of application, and have that batching process take place with me just running it as I need to. Whereas the logic app is kind of going to be a one and done type of thing, but it happens every time an event happens. Does that make sense? hopefully to separate that a little bit. Cool. Nice. Okay, so cognitive services. I haven't played a lot with this, but it is a really fun space. Again, you can do some really cool stuff with it just out of the box in some of the demos, but you can do things like computer vision, which the MCW stuff that we'll talk about here at the end does do some computer vision stuff in it to read license plates. Really fun. You send off a picture. It uses OCR, optical character recognition, to do that. It's pretty much plug and play. And again, low cost for entry. And then, of course, you might pay a lot more if you start using this in a production scenario. But other things, speech, recognizing speech to text, or translating languages, or potentially you might be doing decision making using AI. There's a lot of AI built in as well into the security things at Azure as well. So they have been working on detecting denial of service attacks, and they use their machine learning and their AI stuff behind the scenes to help recognize when those are happening. And that stuff is built into your services as well, which is fun. There's also a new thing I heard about called OpenAI. And OpenAI potentially has the ability to help you with things like writing blogs, basically generating content for you, which is an interesting concept, I think, worth looking into if you're interested in that. But the cognitive services does give you, those different things you can do. Again, you can build bots to help with your knowledge bases, have hundreds and thousands of Microsoft Word documents out there that you can search through. You can also use these to do things like read through everybody's email and look for secrets being displayed, or sent out in an email, so you can flag inappropriate emails and all that jazz, which has some good and some bad ramifications, right? But it is there for you if you want to look into that type of thing. And then big data and streaming. So again, if you're into big data, you may have already been using different platforms on this. So you may have something like Databricks, which is an Apache, has Apache Spark notebooks. You may have HD Insight, which is another open source platform that does big data. The cool thing is these platforms are available at Azure. And it's not just that they're available, they've gone to great deal of effort to make sure they're available in a way that works exactly how you're used to. In fact, to the point of working with the inventors and the creators of Apache Spark to make Databricks work exactly like you would expect it would. So it's not just Azure or Microsoft's implementation of this, it is Microsoft's implementation designed and created with the people who wrote the original Databricks, right? So you're not getting some kind of like wrapper on this thing that's just gonna sort of work. It actually works like you would expect. Now, what's really cool is that Azure also has their own data warehouse. It used to be called Azure Data Warehouse or SQL Data Warehouse. It's now called Synapse Analytics. And this is where we're typically going to store big data as .NET people coming from the SQL side of things. We're probably in the SQL Server, SQL Data Warehouse type of world. The Synapse Analytics, though, gives us the ability to do both SQL Server and Apache Spark. So if you need both, you can do it, which is really cool. Data Factory is the Azure version of SSIS. So if you've used SQL Server Integration Services, you would be familiar enough to start working with Azure Data Factory. There is a learning curve, it's a little bit different, but you can actually import and run existing SSIS packages in Data Factory. And it is where you're going to go if you need to do things like bulk loads or move this data from one database to another, just like you would do with an SSIS package. Take an Excel sheet and bulk load it into my database. Look at Data Factory for that type of thing. And in the IoT world, again, I love to go here because I just think it's fun. You have the IoT Hub, which is the event hub for IoT. So it's basically the same thing as an event hub, just a little bit more designed for IoT. So it takes in millions of records per second for telemetry. You then can put things like stream analytics behind that. And so what typically happens with IoT is we do this thing called a Lambda architecture, where we have a Lambda path where we have the hot data going directly to people making decisions and the cold data going to data lake storage, essentially. And the reason we do that is because we need to know, all the trucks that right now they're melting, we need to get those on our dashboard so people can call the drivers and get them to the gas station so they can plug in as fast as possible or get repaired or whatever it might be. So we need that hot data right now. But that cold data of the millions of records that are coming in, we can store all that, and then we can go back and do our time series insights on top of that, where we do, again, the different windowed looks at postmortems. This is the week leading up to our big holiday sale and what happened the day of our holiday sale, and then the 3 days after, that type of data or whatever. And they have a device provisioning service, which allows us to onboard the IoT devices into our Azure IoT hub, basically. The IoT Central is a separate platform that allows us to build IoT applications. So even if you don't know anything about IoT, you can go to IoT Central and do some of their different samples that they have there and see how to use these tools to do that. And then ultimately, digital twins is a new thing as well, where you can actually electronically model your assets and then use those to take in telemetry in real time, see that, and then process it further. So that's the cool stuff around IoT. All right, so when it comes to the architecture of working with serverless, so we have to start thinking like serverless developers. And we first started off, we had monoliths. We're probably all used to and familiar with working with monoliths and the life cycle that happens around those. We started using n-tier layers of applications where we have our data layer, our business layer, our web layer, or UI layer, whatever you want to call it. And now we have this new thing called microservices that everybody wants to do, microservices. So we can do all of these in the cloud in a serverless architecture. It will be harder to do a monolith, but you can do it. It's very easy to do an n-tier, and then of course microservices is extremely easy to get going, but the payback in microservices that it's much more difficult to manage, because now not only do I have all these pieces, I have to remember which piece goes where and when, but they're smaller, so I can get faster cycle times on them. I can deploy an Azure Function app every day and only affect the functions and not the entire monolithic application. And so that's basically where these different architectures come into play when that happens. When it comes to deployments, again, we're looking at infrastructure as a service or a hybrid. If you're moving into the cloud for the first time, you might write ARM templates, you might deploy them. That way, you might have some sort of network connection that goes between your data center and Azure, unlike an Azure Express route to connect between them. But you also have now probably what we're mostly going to be working in is the platform as a service. The other things that are important to keep in mind are your software as a service, which is things like Microsoft 365 or SharePoint, or things that you just basically provision users into. And then there's this idea of containers or functions as a service kind of being its own type of thing outside of platform as a service, even though it's really platform as a service. And the overall serverless architecture of our deployments, just getting things out there, making sure we have them done at the right time in the right order. So what does that mean for us? That means we need to think about things like, how are we going to manage the state of our solution? Are we going to do it in a stateless manner? So if we're using a bunch of Azure functions, how do we make sure that we have the right execution order? Because we don't want each function to be aware of each other. We just want them to be kind of a single standalone unit. Well, if we have to manage state, we have to consider that. Well, how does that work? The other thing to keep in mind is long-running processes. So we look into things like a fan-in and a fan-out architecture in Azure Functions, which gives us the ability to start with one, fan out to 3 or 4 functions, and come back into a completion function. The other thing to consider with Azure Functions is the idea of warm-up time. So I mentioned this earlier, but if you do a function app that's consumption-based, it does have a cold start, just like you would expect from an app that you're not paying for on maybe a platform provider. There's that first couple of minutes where it's got to start up. Now an Azure function has a cold start on every time it executes when it's consumption based, but it's not very long, it's milliseconds. But it's enough that if you're doing this over and over again, it's worth considering, do we move to a premium plan where it's always on, right? Or an app service hosted function where it's always on. How do we scale? How do we monitor? How do we use the tools at Azure to do the things we need to do? We need to work that into our workflows. And so the cool thing is monitoring can trigger alerts that can send notifications to our Slack, our teams, or us. We can also have auto scaling rules. So we can set the rule that if the servers are seeing more than 80% of CPU usage over the last hour, we spin up another version of it. So we scale out, we add another instance. or we can have something where we have, a scale up and down where we just add a compute power. Maybe we go from a standard plan to a premium plan for the weekend or something if we know we're going to have a lot of traffic. There's also dependency management. When you have all this different stuff going on, like how do we make sure that the correct dependencies are in place? How do we fail gracefully? How do we recover from that failure? And what does it look like for versioning? And some of that comes into play with things like the API management as well. So API management is a nice tool that you can use on top of your platform services. So it's its own platform service, but it gives us a facade that lets us have all of the endpoints we need connected, available to our customers. And we can also do things like subscriptions and products around those and do different reselling amounts and things and throttling requests on the API management, which is a really nice tool. Different design patterns to consider. Sorry, I need to speed this up a little bit. I'm going a little long here, but ultimately we have scheduling, we have CQRS, we have eventing and triggers, transformations, we have the web and API patterns, we have different data patterns and streaming patterns you would want to look into depending on the needs you're doing. And of course, the business uses are going to help you determine what tools you're going to use. Any questions so far? I know there's been a lot of talking. I hate a lot of talking, but it gives us that good overview. So hopefully it's useful.
Only not really like a specific about this. It was maybe it's a little more like about microservices and stuff. I see a lot of time like in referring to like Azure functions like microservices, but I wonder about your opinion because it's like to me it's more of a deployment model than really about microservices because like I've seen people do like a Docker container that has a bunch of endpoints and they still call that a microservice, so like I feel like it's more about like what you're doing in your solution than you're deploying maybe everything as individual functions, but it's not really necessarily microservices because you probably do a monolith in a whole bunch of endpoints, a bunch of Lambda functions,
Yeah, so you get me on a little bit of a soapbox here, but most of us are monolithic developers. I mean, if you've been around for 8 years or more, like most of us have you've probably been working mostly on monoliths, right? And so it's kind of like, what do we do when we go to microservices? We end up making these monolithic microservices, which is almost the worst of both worlds. Yeah. Because now, like you said, you've got one container that's got 15 endpoints and you're calling that microservices. Well, is that a microservice? Is that just an API, right? So Azure functions are great because they can be independent units of work, and containers are great because they can be independent units of work. So I've seen people talking about their containers, each container being kind of a microservice, and then that's when maybe Kubernetes would come into play even more because you're like, okay, we got to orchestrate the life cycle of these specific containers for this microservice, these for that one, etc. That might be kind of where you're going to end up landing. But again, the danger is that whole, well, it's a monolith, but we've just separated into microservices. And now we still need part A's, B, and C to work. So part C can do this so that we finally get to part D that works. Well, are we really building a microservice or are we just building a disconnected monolith at that point? Like it's like still tightly coupled. So it's I think there's a mindset shift. It's like, okay, if I'm going to do what I call a microservice, it should be fully independent of everything else. And so I think the entry point for that I've kind of often recommended is find that one thing that is very small, self-contained, and doesn't matter what application is using it. Maybe it's like a proprietary calculation you have that's always going to be the same. And maybe in the past you've repeated that code in 3 different places or something. Take that out, make it its own microservice. And think of another thing that kind of came up in one of the conversations, which was interesting, is if you could resell that functionality, that might be a good microservice, right? Like I can resell my calculation, I can resell my algorithm to do this, I can resell this, but all of a sudden I've got this thing that's like actually a service, right? That's a good way to think of it, maybe. I don't know. I'm no expert on it either.
I just wonder because of like, I think you're right, but I still think that they could have multiple. They could have 15 endpoints as part of that service that you sell. That's why I wonder because like I was looking at that eShop on eShop Web or something. I can't remember the exact name, but it's the Steve Smith or Dallas put together, and it had Kubernetes had a Docker container, but it called microservices. And I haven't seen anything yet. Like, and not say I looked hard, but that uses Azure functions in one of these microservice projects. And I was just kind of curious to see what like an example project, like are they doing a C# project per function? and that's how they are breaking this down, or are they, like how, I'm just curious on how it's set up. I just want to see, because I've seen the Azure Functions and these things being a good like integration tool, like some of the things you talked about when it's better than the Logic app. There's good things, but I'm just curious to see.
Yeah, that's, those are great questions, because like you can put like a bunch of Azure Functions in one function app and deploy it as a unit of work, right? Mm-hmm. That whole thing goes together. Or you can do, one-offs, one function in an app or one function by itself, right? So yeah, that's a great question, because what works the best for what you're trying to do? And you end up with 15 functions. Well, if I deploy the function app, it's going to redeploy all 15 of them, right?
Yeah. Yep. And that's the thing. I just wanted to make sure we're not making any mistakes or doing it right. So I'm just kind of curious about examples, and just, that's why it's fun just to talk about it anyway, to see.
For sure.
But I think these are all good deployment methods, and they're good things that you can have that makes your deployments easier or gives you some kind of flexibility on scale and other stuff. But it doesn't necessarily make you change your architecture always, and that's the thing. I wonder, but yeah.
Yeah, and the interesting point you make there is scaling too, because if you put it all in one function app, that function app scales as a unit, right? Whereas if you do your functions individually in their own apps, you could scale the functions more individually. So that would be a very important thing to think about. Because if you have one function app or one function that's really going to be a resource hog, and you need to scale your whole app because of it, you may be overpaying or something. I don't know how that would work. Yeah.
That's good to know. I didn't know that. Okay.
Yeah. So cool.
Thanks.
So file storage, a question came in on file storage setting it up to be accessed like a network shared folder. So as far as I understand it, yes, I would say yes, but through code, like you can access it through the normal SMB protocols that you would through any other to access your normal file shares. As far as like a user, being able to upload it to a drive letter, I'm not sure about that. You might have to use like the Azure Storage Explorer or something as an intermediary, or some other proprietary code. I would have to look into that to see how that would work. But it is supposed to replicate what you have on a SAN server. So if you're using that as a shared folder, the typical solution would be to move that to Azure File Storage. That's a great question. So I would need to look into see like how does that work to map it to a drive like you would typically, like the T drive that everybody's using or whatever to share your documents within your company. So there may be a way to map the network drive directly to Azure. I would have to look into that. TLDR version of it, I guess.
I'm sure. I think I saw that in AWS or something like Storage Gateway or something. And I feel like there's probably something similar on the Azure side, but not.
I would think there would have to be, but I'm not 100% sure, so I'd have to look into it. That's cool. All right, so I wanted to do some lightning demos of a couple things and then finish up with some more slides after that. So what I'm going to do, I'll just leave this guy here and we'll just skip through the slides without looking at them. I want to just take you into Azure and go over a few things that are important for us as .NET developers and just kind of go down that route, starting with our storage and different aspects of that. So I've pre-deployed a couple things here, and just real quick, so that you can see this, and I'll delete these later, so seeing the keys here isn't going to hurt me. But basically, just a couple of real quick AZ-CLI commands to create a resource group here. That'll be better. So these are kind of the commands to create a resource group, and I can drop these out on a repo or something later too, so we can have them. I created then a storage account with just local redundant storage that I could then work against, and then I created a storage container. And this storage container here is just basically where I'm going to store some documents. So what that does is that gives me this demo storage account out here at Azure. And if I look at that right now, all I have on it is one container, and just ignore those. The containers that I created is that imports container. And I just did all this through code, but you could easily do this through the portal as well, or through ARM templates or Terraform or whatever choice of Pulumi or Bicep or whatever you want to use to do it automated, you can. But the reason I wanted to do this is because I wanted to take a moment as a .NET developer to say, well, how do I interact with this in code? So ultimately, I have these containers out there, and right now I have this blob storage, and the access level of it is typically public, right? So public people can read it, but I can change that to private. As long as my account can go between public and private, my containers can be toggled. If I set my account to be a private account, then they have to all be private no matter what. Right now it's private. That means nobody can just read it from the web, but I have access keys and I grabbed those. And this is going to be a very similar pattern you'd see with any code you're writing, whether it's against Service Bus, Cosmos, whether it's against Azure Storage or whatever. You're going to look for some sort of connection string, and you're going to use an SDK to leverage it through that connection string. There's other ways to do things with credentials and such, of course, if you want to do that, and you can store these things into Azure Key Vault if you want to abstract them from your developers and have your developers work through different tools to get to Key Vault without actually knowing what the keys are, or actually accidentally committing them to GitHub or whatever it might be. But ultimately, these Azure keys, what they do is they give you, you get a key and a connection string. And what I tell everybody is you have two, usually most of the things will have two different versions of the keys. So for like your really high important things, you would use key 1, and for things that might get compromised more easily or less important, you'd use key 2. And the reason I say that is because you can generate things based on these keys, specifically for storage, shared access signatures, so people can read private variable or private blobs for a temporary amount of time or whatever it might be. Use key 2 for that, because then if it gets bad or compromised, you could rotate that, and your apps are using key 1, then your apps still work, right? So it's really cool, a little ecosystem there. But ultimately what I did was I quickly whipped up a little demo app here earlier, and it didn't take me but 10 minutes because it's a very simple thing to do. These are very high level. Let me just pull this over to the screen once it loads here. And ultimately all this is a console app, and let me make this a little bigger so it's easier to see. But when you're doing anything with code at Azure, for the most part, you think of the hierarchy. So when I'm doing my connection here, the first thing I need is a connection string, which is just that key from my account. I just stored it in app settings in this case, but typically you'd put this into your secrets for .NET Secrets, or you'd put it into Key Vault, and you'd just leverage a Key Vault key here that would then, you'd have to have credentials set up and all that jazz, which I didn't go to that level. You create the blob service client then, so this is the top level to connect to my account on that connection string. And then I need a container, so I just have that container name in my config for whatever reason. You create the blob container client. I just have a local file here called 1.jpg. I'm going to go ahead and just upload that to my blob storage as a file stream. So basically just real quick code to upload a file, and then ultimately from there, I'm just going to list out my blobs. Now there's plenty more you can do. You can create, update, delete, you can check for things, you can create containers, you can do all the stuff you want to do through the SDK. Again, this is very high level, just to show how easy it is to quickly run. I'm going to go ahead and create my account here. There it is. So it listed my blobs. I got 1.jpg out there. Yay, exciting stuff, I know. But if we go out here now and look at our containers and we look at our imports, there's 1.jpg. It's there, and it has a public facing URL. Let's see, can I move this over? There we go, cool. And ultimately, if I hit that right now, it says I don't have access, which is cool. That's what I wanted. I turned it to a private access only so nobody could see it. And the reason I did that is because I wanted to quickly show you the idea of a shared access token. And so what happens is when I create a private blob, there may be times when I need a client or someone to interact with that blob for a temporary amount of time through the URL and this token. And so ultimately I can create this shared access token. And I can do it at the container level for everything in container, or I can do it specifically for a blob. And again, I want to use key 2 for these. The reason, again, so I can recycle it if it gets compromised, and then my app still works. You can give it whatever permissions you want. So in this case, let's just do read. You can give it a start and end time for expiration and start, and you can give it IP address ranges and protocol limitations. Now, the really cool thing is that this is all contained in the shared access signature, and it will actually you'll be able to look at a shared access signature and know what it's doing for you. Now my little Azure mask here is hiding that, so give me a second to turn that off so we can see it. But you see that it's a storage protocol or service. You got read, your start time is this, your end time is that, there's your protocols, HTTPS, and then there's different, this is a container, and then the signature. So the signature is the most important thing because that's what guarantees that this actually works. And you see that through the through that service, that shared access service token right here at the end is how I get access to that blob on that same public facing link. So I just take that URL query string parameter and I add that to the end of my original request, and there's my image, and my image pops up, and I have a lot of kids, so I thought this was really funny. Maybe you don't, I don't know, but I thought it was funny. So I thought it was worthy of putting into a blob storage account for fun. Anyway, that's how easy it is to make it publicly accessible for a brief period of time. Once that token expires, it's gone. Shared access tokens are not able to be revoked if you import or if you create them this way. If you do it on the fly like I just did, not through a policy, then every single one is independent, and the only way to revoke them is to recycle my key. If you have a scenario where you're doing this and you want to have a bunch of shared access signatures that you could revoke at the same amount of time, you can use these access policies to do that. You create an access policy and you generate your shared access signatures through the policy. If something's wrong with one of the players that's using one of those, you can recycle the entire policy. Everything that was issued by it would automatically be recycled without doing your key. So just a couple different ways to do things. But that's storage. I mean, it's that easy to work with. It gives us a chance to read and write to it from code. We can do that from our web apps. We can, make them publicly accessible or private. Even if it's private, if we have the keys, we can get to it and work with it. It's awesome. Cool. So the next demo I wanted to do was around Service Bus. Now, Service Bus is typically, again, going to be my messaging. And the reason I want to do this was specifically asked about queuing. So I wanted to make sure I got this in for you guys to see it. Again, as a .NET developer, if I want to start disconnecting my applications, the typical way I would do that would be through some sort of queue or messaging that I would allow myself to be able to send a message into the queue, and then the rest of the application could respond to it. It's really great for making sure that one end of the equation doesn't overload the other. So if I have a back end that doesn't have as much power and I spin up 3 versions of my front end, I can take in the entries from my users during my sale as much as I want, and then even out the load on my database processing or whatever I'm doing down the line with my queue. So working with the storage queue was just about as easy as working with the storage. So basically you do the same thing. You have to have a namespace for your queue. So that was this code here. This is just AZ-CLI in a bash terminal. Just created a namespace name and created it on the same resource group. It needs to have a queue. So this was the queue name being created. And it takes just a couple minutes to run these commands and you get it. And once again, you get your endpoints and your connection stuff. And then I also have this link if you're interested in working with the queues. There's a link that just basically takes you right through the code there. Cool. So what I did for the service bus was I created a consumer and a publisher. And so the publisher and the consumer are separate applications in this for reasons, but it's just very easy to keep them separate that way. So let me get these open quick. I guess I should have opened these earlier. I apologize. But again, the code here is very trivial, but it gives you enough of an idea that you could start taking this and use this in your real apps, right? So that's my storage again. So let's close that down. There's my queue client. I keep getting back to storage, sorry. Okay, so here's my publisher. So this is going to publish to the queue, and they're very similar. Once again, I just put keys into my app settings, but you would, again, not want to store them there because you don't want to put your access keys in GitHub ever. That'd be bad. I took the code they gave us, which is a connection string, the queue name. You have a service bus client and the sender in this case. And then I just set the number of messages to 5 because it seemed like a nice number. You get the connection string and the queue name. You, again, create your client. Once you have your client, you get your sender from that. So just like we had an account and we got the container, we get a client here with the sender for the service queue specifically. And then ultimately, we have this batch object to send in a batch. And so here we have the number of messages, whatever we set, which was 5, and it's literally just gonna create messages for that by doing this message batch.triad, and at the end of the day, it's gonna send those off. And so there's a send message async is the main method there. So nothing major here, but you can see how easy this would be to work in your queue with your code. So I'm just gonna run this one on this side. send off my 5 messages. Hopefully everything still works. Batch of 5 messages has been published to the queue. So I'm going to disconnect and basically turn that off. In the meantime, we can look out at our service queue here. And on Azure, what we'll see is that we can watch our messages happening. Again, just ignore my little pop-ups here. And let's turn this back on for a second. Sorry. So again, we got our keys from the shared access policies here. This is the root manage shared key. You can give it manage, send, and listen rights. So you can do individual rights for sending and listening if you want to on specific keys. So your connection string would only allow you to listen and read, for example, or send and not read. There's a lot of other things to look into with queues, but ultimately once you create them, you see that you have different delivery counts, different things going on. It has this public-facing queue URL. Ultimately, it has dead lettering if you want to turn that on, which is what happens if you send the message and nobody receives it. It's called a dead letter. But you can see what we got right now. We have 5 active messages. Ooh, great question. Can you write binary data to the message bus or only text? And boy, you're putting me on the spot here. So I believe binary data is what you are, actually, yes, binary data is what you're writing to the message bus. And in fact, if we look at, that's a great, yeah, because we are definitely serializing it, but it's serializing it automatically, binary, I think, if I remember right. Wow, great question. When I created that, the publisher, so we were sending the message here, and the messages was sent in a message batch. And I would have to look into this in more detail how this works, but I do believe, oh man, I should know this because this is like an exam question worthy type of thing, right? I believe it's binary data that you're pushing into the service queue. And then ultimately it's reading it back, but it's serializing on their side. So if you want to do further serialization on your side, front and back, you have to do that yourself, like JSON or something, right? But yeah, I would, oof.
I didn't mean to bring back bad memories from the exam days. It was just curiosity got the best of me.
Yeah, no, it's a great question because it's a very important thing. I do believe it is binary data automatically in Service Bus, but I'll have to look at that again.
Okay.
I'm so sorry.
No problem. Thanks, Brian.
Yeah. So cool. Great question. Sorry, I don't have the confidence to answer it today. But what we end up doing then, we do send those messages out there. They're out there at Azure. So they're sitting there in my queue right now, waiting to be handled. So we see that we can watch the spike for the last 6 hours. You can see when I tested it earlier today to make sure it was going to work, and ultimately then now it's working again in the last hour. So you can see that coming in, and then ultimately on my reader side, my client consumer is exactly pretty much the same code. The only difference here is instead of a sender, we're going to do a processor, right? So now we have a client create processor on there instead of a client create sender or whatever it was before. And it's going to get that, the client processing is going to be done from the same queue that we just wrote from. Again, it has to have the right connection credentials or it won't work. And then coming back from there, ultimately, that message is going to be processed on our side. So when I run this, we'll just get our 5 messages out of the queue, basically. And there they are. So they waited for us, they were processed, we were good to go. So we disconnected, but it's pretty much that straightforward. But again, you can look more into it on that link, which will take you out to working with the code on sending messages to and from the queue. This was the .NET version, of course, but there are other languages available. Cool. I wanted to show you quickly, I know we're running kind of low on time here. I wanted to show you Azure Function App and a little bit about that, as well as an Azure Web App. And the cool thing is, I wanted to show you some CI/CD around it to kind of do that. And then at the end, I'm going to point you into a direction. If you want to learn more about this, run through the Microsoft Cloud Workshop. I'm going to get you the directions for that. But you can see, I have quite a few already, Azure Function Apps out there. They cost me nothing if I'm not using them. They're literally almost free. There's maybe a penny of storage I'm paying for each one of these. because on the consumption plan, you only pay for what you use. So you create a function app at Azure, just like you would create any resource. So you just find the right resource group to put it in. You have to give it a unique name. It's a public facing URL. So we're just going to call this function app 2022-0217 with my initials, so it's unique enough. I'm going to do a code here, but you can see you could do this as Docker container if you're into that. You can also choose what stack you're using. I'm going to use .NET, and my version is going to be 6. So they have 6 and 3.1 here available. And I'm going to do this. I'm going to actually just put everything in the north central US for today, just to kind of keep it in the lower, used region or whatever. I'm not doing any kind of replication, so I don't care. My storage account that backs this then is automatically created. So again, when I create a function app, it does have a backing storage account. That's also where I think the state is stored. If you do like durable functions and such, it's kind of using that storage account on the back end. You can determine if you want to use Linux or Windows based. I'm thinking with .NET Core, you could probably use Linux, but I'm just going to go ahead and stick with Windows because that's what I know. And my plan here is consumption. Again, functions premium or an app service plan is what I would choose if I want to have more control over what I'm doing, or if I want to avoid cold starts. And cold starts are a real thing, so just be aware of that. Consumption does have a cold start on each execution. You can set up networking on your private plans, put it on private network, different monitoring stuff here with application insights built in. I have tags, so every resource at Azure can be tagged. Tagging is highly useful if you need to relegate billing to a certain department or customer or client. You tag it appropriately so you can do cost roll-ups across resource groups and even across subscriptions based on tags. It's also nice if you want to do things like segregation of environments. You can use tags to say, this is my production version, this is my test version via the tags or whatever. So you always have to just review and create. It has to pass all of your validation behind the scenes to make sure that you have the rights to do this and that you aren't blocked from doing that. It creates the function app out there. And at this point, you can actually go into the function app and write code in the portal and create functions if you wanted to. For today, I'm going to actually do a deployment from GitHub. Now, while we're waiting for that, I also want to quickly spin up a, let's do this way. I'm already logged in then. Let's do this. Let's just go to an app service here real quick. So app services, again, give me the ability to also create a public-facing website. This is our typical .NET development route if we're going to create a website. We would go create an app service. App services are going to be powerful enough for pretty much everything you need. You don't have to containerize. You don't have to go Kubernetes. You can do your stuff in web app services and you're going to be just fine. So, you can choose all the way up to premium tiers where you can isolate and do way powerful instances. And even the typical production level instances running about $60 to $70 a month, so it's not bad at all. But they have free ones now for developers, which is even better. So we'll just do this app service 2022-0217 BLG, so it's nice and unique. Again, code, Docker, or static web app now is a new thing as well. I'm just going to do code. I'm going to do this on the .NET 6 version. Again, you see .NET 3.1, 4.8, 3.5 even. If you have a 3.5 app that needs to go out there, congratulations, you can do that, which might be the best thing that ever happened to you if you're running a 3.5 app, honestly, or the worst thing, I'm not sure. You're creating a Windows plan here, and so you can reuse your plans with multiple app services. You can have, I think, up to 100 app services in a plan. However, just note you're sharing the compute power of the plan across all your instances. So if one of them becomes a resource hog, you're again scaling the entire unit, not just that app service. So here, typically you're going to do 1-to-1. You might do 1-to-3 if you have like a web farm that's all for the same application or something, right? I'm going to just save it on the free plan here. That's actually one that's existing though. So let's go ahead and just create a new one. We'll just call this demo today, whatever it is, app service plan. And again, we choose our size here based on what we want. So we have production, isolated, and dev test workloads. Typical production here is this might be a little bit discounted, but it's estimated to be about $40 to $45 a month. Probably runs more closer to 70, I think, on a typical plan. Here's a free one. You got a couple other limited test options you could use as well, just a little bit cheaper, but you can do like custom domains on these. And this one can allow you to manually scale. So just a couple of other things you can do with those. No custom domains on your free plan, and that only makes sense, right? It was everybody to use it. You can do continuous deployment right here from the web. So this is really cool. I already have my application out in GitHub. So I'm just gonna go ahead and do this. I'm gonna choose my account, select my organization, and then the repository that I'm looking for is gonna be GL demo web app, and the branch is gonna be main. And you can preview the file here if you wanna see it, but it's gonna automatically generate a GitHub action at GitHub, and it will deploy the application behind the scenes without me doing anything else. I'm also going to put application insights on it so we can see that a little bit, review and create this and push it out there. So there's a web app and an Azure function now. So the Azure function's done. At this point, there are no functions on it. So here's the other way. Once you have your app service or your function deployed, if it's already out there, you can still wire it up from GitHub. You just go to the deployment center and wait for it to load patiently. And here we can actually just go ahead and wire this up once it pops up. Again, from any of our favorite sources. So if you're using Azure, you can do that. If you're using local, you can actually do it local. GitHub, Bitbucket. Again, you sign in to your account that you want to be on. You choose the right repository that's based on something's like, there we go. And the branch that you need from your branch that you want, and then the version. So the version of the Azure functions matters. If I'm using .NET 6 or .NET 3.1, it's different versions. So again, the cool thing is though, you can change the version in your GitHub action. If it's wrong, you can change it in your settings on your app service as well. So one thing I also forgot to do is that in order for some of this stuff to work, I'm going to need a database. Because you know, the accounts and stuff. So quickly, an Azure SQL database. And Azure SQL, just create a quick one that is going to be a very single $5 a month version of the database. So we'll do this in this one, which is GL demo, and we'll just call this simple SQL DB. I have to create a server here on the fly. Sorry for this. The server name will just be simple SQL DB server, and the location I'll just leave it East first time, demo user, and some password. And that will create a server. And then the server will go ahead and size this down to the basic tier. Sorry, I'm going a little fast here just to try to save time. That gets me down to $5 a month for a basic SQL server, and just make it local redundant storage. I don't need any backups or anything running on that. So we'll create that so that I can wire that up to my Azure App Service here in a second. In the meantime, let's look at GitHub quick. So at GitHub, I have those two repos. The two repos now should have actions on them. They're running at this point to deploy the app service here from the GLG net demo web app. And this one is the Azure function app. So you can drill in and see that I didn't have to write any YAML and it's working for me. Now how this works for both of these in this way is that it is using an app repository secret, and it's using the published profile. So if you don't like that, you can create service principals and you can deploy them with other GitHub action using the service principal. But these are very easily done automatically with a repository secret for the published profile. So just like if you literally go get the published profile out of a .NET project and then import that into your Visual Studio Code or Visual Studio and then publish from that profile, that's literally what this action is doing. It's storing the entire XML for that published profile right here in a secret. So if you ever need to change it, you have to change that. You can't review them, you can only update or remove them. You can't read it. So just know that on a secret as well. But once that's done, they'll be deployed, and we'll have also this SQL Server database that's going to be out there. And this will be interesting because of migrations. I may have, let's see if I did this. Sorry, we're at a kind of an impasse with waiting for some deployments. What questions do you have? I'm going pretty fast trying to wrap up here. Questions do you have about stuff so far, if any?
I have a question about the storage accounts, actually.
Sure.
So I interact with one for work, and I was looking for a way a while back to delete a particular file by name from my storage account, and I was not able to find one. So ultimately what I did is just downloaded everything and then wiped the container clean. But do you know, is there a way to do it where you can selectively remove from a container?
So you could do it through code. You could have connected through your code, and you can list your blobs. So that's what I did here. So here's my blob item.name. So I could find the ones that match a pattern, maybe with a regex or something, and then do a delete with that code. That's one way, potentially. There's Azure Storage Explorer as well. This has the ability for me to look at my storage accounts under my subscriptions and be able to see stuff. And I might be able to manually search for what I'm looking for here and then select all of those and delete them, if that makes sense. So like maybe I was looking for something that started with 00. Yeah, that's not working. I don't know how to do it here, but there might be a way to do like something where you could search and find, you know, specific resources here, and then delete them. But this is just a tool called Microsoft Azure Storage Explorer. It's a free download. It looks a lot like Visual Studio Code. Basically connects to storage accounts. And the older versions let you do Cosmos, the newer versions won't. So I haven't updated because of that. We found that out the other day too, which was interesting because it's like, oh, don't update. You can't connect to Cosmos anymore. They're doing it a different way through the web or something now. So, but yeah, that might be the other way. You can also do policies on your stuff. So maybe out at Azure, you could have your, go into your storage account and look at, sorry, got so much stuff out here now. All of a sudden, go out to your storage account and on your container, you can do policies. So you can do policies that would be like, okay, I want to delete every time, you know, something's older than 30 days, or I can delete if it hasn't been accessed in the last 30 days or whatever. You can also do policies to move from hot to cold or whatever in that same way. So you could maybe do something like that if it's not name specific, where it's just like, we have these files out there and we want them to be done every 30 days, we want to purge anything that's older than 30 days or whatever. And that would work on a policy. So that might be a third way you could approach it. Cool.
Yeah, it makes sense. Thank you.
Yeah. Okay. So yeah, real quick here. When I get my Azure database done, I can get my connection strings from it here, and it just is the connection string with all the information, sans the password. The password's not in that. So typically I just bring that into a notepad quickly, and then I'm able to, write my password in there manually. I'm doing that on the other screen for reasons. But it's when I want to connect this then, so my application is looking for a connection string in its code, and the connection string is typically going to be called whatever the default is, like default connection string. So probably looking for default connection in this case, and that's building that. And then see, I should have turned on some of the stuff, I think, to automatically run migrations or do some other stuff there. Oh, this is already going to do it. Only in development though, shoot. Okay, yeah, so this may not work just because I don't have it connected, but once I have my connection string, I'll go to my app service here out at Azure. Sorry, this is where it starts getting clicky for me in the demo. We just did that one today. So you go to your configuration. Under your configuration, you'll note you have your environment variables, things like your app insights key is here. You can also put things like an app config key here. So like the app config is a way that you can take the things that are in app settings and put it in a place at Azure that you can use amongst a number of applications. So you don't have to do this everywhere. You do it in the Azure app config, and then you leverage the Azure app config from this environment variable. And now I have all my keys for all of my applications in one place. Either one can connect to Key Vault to also obscure your stuff as well. and this is where I do the connection string, so it's just default connection. And then I paste my code in here, and then I ultimately switch this to SQL Server or SQL Azure, either one. And I go ahead and do that and save it, and that will reboot my app service. And once that's done, then I have a backing database on my app service. And if I have migrations automated, it would kick off here. If we see the 503, it's because my migrations aren't automated. Oh, cool, look at that. It worked. So this one also has stuff in place that you could go out and use the Azure app config and put it in the app config value and then set that, and it would show that here. This one is for some demonstrations I do where I actually do it against Key Vault as well, and then read it from Key Vault and show that here. The database now is backing this, so I should be good. What's really cool is I can go to this application insights on this one. I have things wired up, tells you how to use it here, but ultimately I'm running some code behind the scenes, some custom metrics and such that's running against my app insights. And so as I go out to my app service here, you can see on your app service, you have application insights, and the application insights has tracking that's going on. You can create dashboards around it. You can do things like an application map, which tells you, I don't have this on right now, but it basically tells you, I think maybe it just needs to warm up, but ultimately it would show all the database commands and such that I'm doing, or storage account commands, everything that I'm connected to. It's an app map. It's really cool. But even more fun is live metrics. Live metrics, as long as your app is up and running and the connection keys are there correctly, now what we can see is, if I run this, sorry, too many windows open, and I hit this again, that's the wrong window, isn't it? Shoot. Where did it go? Lost it. Where did my app insights go? Darn it. I lost it. All right, I apologize because that was, I missed out on the coolest thing that I could have shown you there from today. Oh, I'm hitting all the wrong buttons, and in my rush to be hurry, I'm hitting all the wrong buttons. I apologize. Just gonna slow down for a second. And this was all the other stuff I wanted to show you. Look at this. Go back into the clickiness here for a second. App services. Oh, let's just go straight to, yeah, app services will be the easiest way to get there. Go back to my app service. Again, click on my app insights. Click on my insights data. Click on live metrics. And let's make this a little smaller. There we go. So now we can see, as I'm hitting the page, you can see custom exceptions being tracked, as well as custom events that I've written in code on that application, writing to app insights. So I can test it, I'm wired up, and you can see it all coming in live, which is pretty cool. And then finally on the function app, we deployed earlier as well. That should be done now. And that was function app 2022. That one got deployed. You can see now that it has a couple of functions, hopefully, maybe. Uh-oh. The runtime is unreachable. That's fun. Okay, well, what we should have seen here is two functions, and we should have been able to drill into them. For whatever reason, we can't. So let's quickly go to finish up. The last thing I want to tell you about is this Microsoft Cloud Workshop. And this is what I ran for the remainder of the 2 hours at CodeMash. And ultimately, it's free, and you can do it on your own time if you're interested in learning more about these technologies. It's on GitHub, but if you just go to Microsoft Cloud Workshop, and this is kind of like my secret weapon when it comes to studying for exams, because ultimately these have a lot of really cool things that you can do. So the Microsoft Cloud Workshop has a number of little different scenarios that you could run through. This one is called Serverless, and it's called Serverless Architecture. And then ultimately it's out at GitHub. And at GitHub, they have a whiteboard design session and the hands-on lab. And the hands-on lab is literally a walkthrough of doing this stuff where you would build out this architecture. And the architecture is, start out with your blob storage, upload your vehicle photos. It's going to respond to that with an event. The event is going to trigger through the event grid to trigger a function, which sends it out to the computer vision. Ultimately, then, once it gets done here, it triggers another event, and the event says, okay, we got the data. Either it's processed or it's not, puts that into different containers at Cosmos, and then ultimately exports it to a file or to a logic app, which sends you an email. So it's a really cool way to see a serverless architecture. It has App Insights working behind the scenes as well as GitHub Actions. So it's kind of got the whole gamut of the ecosystem. So it's a really nice little thing to run through. It takes about an hour and a half probably the first time, maybe an hour and 45. And then once you do it once or twice, it becomes a little quicker. But at the end of the day, you end up with a solution where you basically have a bunch of containers out there. You get images that you're uploading. When I drop this, it's actually running an event behind the scene, which is a subscription to an Azure function. And that's going to actually process, it's going to trigger an Azure function execution when I drop a file in there. So if I go out here to my images and I grab one of my license plate images that I close down now, of course. Yeah. So give me 1 second. That would be under here, serverless, hands-on, repo, source, license plates. Okay, so here's some images, and then ultimately, if I drop one into there through Azure Storage here, it's actually uploading it to the blob. I'm going to go ahead and replace this. What will happen is then that will trigger my process imaging function to run. That will send that off to the cognitive services. Cognitive services will then say, oh, we've got a license plate we could process, and it will then put that image data into my Cosmos DB, which ultimately goes into the Cosmos DB here. So the last thing, sorry, I keep saying the last thing, but I didn't get to show you Logic Apps, so just real quick, the Logic App on that. I have a bunch of Logic Apps too, but the one that we want is going to be like, yeah, you can do Twitter stuff, but yeah, this one here. And ultimately, when you look at a Logic App, you can see the different connectors that you can drag and drop in here. And this one is going to send off that email from that serverless, but I use SendGrid instead of the Office 365. So it literally this one has a timer trigger on it. So it just runs every 15 minutes. I have it disabled right now, so it won't keep running, but you could re-enable it with the click of a button here, somewhere on there on the overview probably. And then, so it runs every 15 minutes. You set all that up. The export license plates literally just goes out and calls an Azure function. You can see different settings around that. You can make them asynchronous or synchronous, which is important. You can do conditions. Here's where it's sending the email to using SendGrid. So very simple, easy to wire up. Okay, so that's probably enough for today. That's kind of the whirlwind tour of serverless architecture at Azure. Hopefully there was some useful stuff in there. And yeah, cool. If not, and if you have any questions, please don't hesitate to reach out. I'd love to connect with you again. I think it's funny because I have the same finishing slide that you had for your questions. So I'm going to show that quick. Let me just bring up my final slides here. Again, the MCW stuff, don't forget about that. There's some really cool stuff out there. I like to plug that program. I love that program, and I don't ever want it to go away. But ultimately, this is my contact info. Brian at Major Guidance Solutions, BL Gorman at Twitter, or Brian O'Gorman on LinkedIn. And I'd love to connect with you and talk shop, or answer any questions you might have, or if you have anything about certifications you're interested in, that's cool. Also, again, I wrote that book. If you're interested in it, go check that out. Also, I'm on Spotify. I'm a Christian artist, so if you like Christian music, you could support me just by listening to my music on Spotify. That'd be fun.
I used to say I work in AWS and .NET, and so it's kind of fun to every once in a while to see what kind of things are available in Azure. So I really appreciate it. It was a whirlwind. It was learned a lot, so appreciate that.
All right. Any other questions for Brian?
Awesome. Well, thank you, everybody.
right.
Thanks again for the opportunity. I really appreciate it. Hopefully you find some useful stuff you can take to work tomorrow and the next days.